Namaste. Welcome to the course on sampling, p-value, power and effect size and reporting results. Part 2. Now we have discussed p-value and we will be discussing power and effect size in this particular lecture. And we will also be discussing how we have to report our results. Statistical power. Now let us recapitulate. We have two types of error. Type 1 error is finding an effect if it is not there. Type 2 error is missing an effect if it is present in the population. Statistical power addresses the type 2 error. While p-value is addressed in type 1 error, type 2 error is addressed by statistical power. Statistical power is the ability of a test to find effect if it is present. It is expressed as 1 minus beta. Cohen in 1988 recommended 0.2 probability of failing to detect a real effect, and corresponding statistical power is 0.8. And generally in most of the research we consider 0.8 as a rule of thumb to be the 1 minus beta. Thus, similar to 0.05 type 1 error, power of 0.8 is aimed. Statistical power depends on the following. How big is the effect? Bigger effects are easier to find, and this is known as effect sizes. Now, if there are bigger effects, we should be able to identify them, and that we call it as effect sizes. And number 2 is how stringent we are applying the criteria of type 1 error. The more stringent about type 1 error, the more difficult to find the effect. For example, in Bonferroni correction, if we do more tests, the probability of rejecting an effect that is existing may also increase. As you can see, it gets multiplied across the tests. If there are 2 tests, 0.95 multiplied by 0.95 will give you 0.90. That is, when we use the correction, the power is likely to come down. Number 2, the sample size. We know that larger the sample size, it is easier to find the effect. Higher sample sizes have less noise and signal can be identified better. We have seen in the last lecture that any statistical test is a ratio of signal to noise or systematic explanation, that what we give for the entire model divided by inability to explain the model. And this ratio is given by T or by chi-square or by f-test. Now, how to calculate power of an experiment or a test? There are 2 alternatives. It is given that we conduct the experiment, the alpha value is already selected. The next step is to estimate the effect size based on sample data. If the value is equal to or more than 0.8, the confidence in the experiment is more. We can set the value of alpha and 1 minus beta as 0.05 and 0.80 as generally being done, and estimate the effect size in the population from the past data. In reality, you can a priori estimate, that is, before doing the test you can estimate the power, or you can conduct the experiment and then find the power, that is post hoc test. In the process, you will be able to identify the difference very easily. Now, please download G Power version 3.0.10 from the following website. It is free software When you download the software, it will give a small icon in your laptop, which I have discussed in the continuation of this lecture by way of discussing the software. Now, in this software, I have discussed a problem. An original equipment manufacturer of auto bulbs claims that its brand will last 450 hours on an average with standard deviation of 50. The car manufacturer who buys these auto bulbs suspect that it is overestimated by 40 hours based on the returns from the customers. Now, how many light bulbs the car manufacturer should test so that there is confidence in the results? In fact, this is the exact power test. We would like to know, I should have enough confidence, at the same time, what is my sample size? Now the problem. The explanation for the problem is the car manufacturer wished to know the sample size of bulbs to be tested. We will start by designing hypothesis from the values known to us. We will also discuss some assumptions we make. Let us start with the null hypothesis. The null hypothesis is 450 hours. That is constant against which we test the manufacturer's hypothesis that the alternative hypothesis is given by 410 hours. That means the population distribution is 450 hours with 50 hours of standard deviation. So this will be a separate distribution. Now, there is no indication of what kind of discrepancy is needed to be tested. Therefore, when we do not know about the kind of discrepancy, we use two-tailed test. Now, significance level and power. Significance level describes the probability of type 1 error, the probability that null hypothesis will be rejected when in fact it is true. On the other hand, power measures the probability that a type 2 error will not occur. In other words, power is the likelihood of the test appropriately rejecting the null hypothesis. Therefore, we will be combining these two in a single analysis by using G power. We will be going through the software G power and will work on the problems, and then you will find how exactly you can find the power as well as effect size and reporting them in your human resources reporting. As a human resources professional, you have to take care of type 2 error as has been recommended by American Psychology Association. You can clearly report these results so that the probability of your paper being accepted becomes higher. I wish you go through the entire process of G power statistics so that you will be able to get a good reporting results.
Namaste. Welcome to the practice session of G power software. G power is a standalone power analysis program for many statistical tests commonly used in social, behavioral, and biomedical sciences. It is available free of cost and you can use it on Windows or on Mac platform. When you download from the website, which I have specified in my lecture, you can see a small icon here. When you click on the icon, you will see the G power 3.1.9.2 coming over here. If you look at the entire space, you will see here the test families. Here you have exact test, F test, T test, chi-square test, and Z test. For example, If I click on the t-test, you have large number of available models. For example, you have means, difference between two dependent means, that is matched pair test, difference between two independent means, therefore there are two groups. You would like to find the difference. If you see the third one, difference from constant, one sample case. Like that, you have a set of statistical tests which you can clearly see, where you can click on in order to use. For example, in the example that I have given in my lecture, you have the entire population. For example, the vendor or the OEM vendor claimed that the life of the part is 450 hours. When the manufacturer who embeds this product in his final good, he found that there are a lot of complaints from the customers. Such that it is having not more than 410 hours of life. And they also know that the standard deviation is approximately 50 hours for the population. Now, the OEM seller claims that 450 hours and the variation, that is the standard deviation, is 50 hours. The buyer or the manufacturer, he thinks that it is not 450 and it is only 410. In these circumstances, what is our objective? Our objective is to find out how many number of samples we can really take in order to have an alpha error probability of 0.05, or the probability of making type 1 error should be restricted to 0.05. The another most important aspect we also want to have is the power. That is, we want the power to be approximately 90% or 0.9. That is 1 minus beta. Therefore, the probability of not committing type 2 error is 0.9. Now, what we should do is, we also should decide, should it be a two-tailed test or one-tailed test? Now, in this problem, we are not very sure about whether it is a two-tailed test or a one-tailed test because no direction has been given. Therefore, we will consider two-tailed test. Therefore, let us first start with the inputs. Now, if we click inputs, you will see two-tail. Now, in the effect size, the convention is, if it is 0.20, it is small. If it is 0.50, it is medium. And if it is 0.80, it is large. These values are given by Cohen, and in fact they are known as Cohen-D. Now let me explain this Cohen-D values. We all know that Z value is given by the difference between two values of mean divided by the standard deviation. In the same way, here also, it is the difference between two values divided by the standard deviation. Therefore, we are converting the units from any units to standard deviation units. That means if the effect size D is 0.5, therefore probably it has crossed 0.5 of the standard deviation. If it is 1, it would have crossed 1 standard deviation. Here, by default, he has put some value. Let us not go by it. Now what we do is the alpha value is 0.05. We will accept whatever that is being given. But the power, we have expected 0.9. Now with this, we want to determine the effect size. Now you will see a side window that is popping up. Now the mean H0, that is the constant value that what you had, is 450 hours. I am inputting the 450 hours, and the mean what we are thinking based on our own research, we put it as 410. Now the standard deviation, we already know that it is 50 hours. Therefore, we will input the 50 hours, and the effect size we will calculate. Now if you see here, it has calculated the effect size as 0.8. Now calculate and transfer to the main. You have transferred the value to the main window. There is no need for this secondary window, and we will close it. Now the output parameters you see here: non-centrality parameter delta, critical T, degrees of freedom, total sample size, and actual power. So this is the effect size, what you have given, and the power we are expecting is 0.9. Therefore here, with the sample size, it will give the actual power, what it will happen if we use these parameters. And the total sample size that we will be using, that we need. Therefore, the first point is we need to know the sample size. And from that we can calculate the degrees of freedom and the critical T value. Now what we do is we will go to the calculate section, and then we can see here a complete graph of the red color is given by the population. The blue color, that what we see here, is given by the sample that we have used. Therefore, the total sample size is 19. Therefore, we need to have minimum of 19 samples to be tested, so that we arrive at appropriate. For example, we need to know the power of the test is 0.90, and the actual power we get is 0.909, which is little higher. And we can also see the degrees of freedom. It will be less 1 from the total sample size. The critical T value is given by 2.1. Now you can clearly know the critical T value gives the alpha by 2. Therefore, this area, if it crosses more than 2.1, it is in the rejection area. On the other hand, the beta value is given in this region. Now we can see both these areas. Therefore, we have determined what is the sample size, and based on the sample size, what we can do. On the other hand, I would like to know what kind of a distribution of values I will have if I have a lower sample size. For example, if I have a sample size of only 15, what is likely to happen to my various values? Now, we will do X5 plot for range of values. Now, plot on the y-axis total sample size. Therefore, on the y-axis, on this axis, we will plot the total sample size with markers and display the values in the plot. It will show 3 digits. We may not require 3 digits. Probably we require no or 1 digit. Now, as a function of 1 minus the error probability, therefore, we would like to know as a function of power what exactly. Therefore, we will start the power from 0.6 and increasing it by 0.1, 0.01 through to 0.95. Now, we have effect size that is already given here. Effect size is given as 0.8 and alpha error is 0.05, and we draw the plots. Now we can see there is a lot of clutter for you to see. Therefore, I think I will remove some of the digits. Therefore, you will see here the total sample size as it goes up to 19 to 20, you are getting almost 0.5 here, 0.95 here. What is the graph indicates to us? Therefore, if you have a sample of only 12, you can see here total sample size 12, you will have a power of only 0.7. Suppose if your budget is only for testing 10 samples, you will be left with only 0.7 power. On the other hand, if you increase the sample size up to 14, you will get a power of 0.8. Therefore, you may choose between 14 to 19 if you are requiring high. The general standard value for good power is 0.08. Therefore, you may start with 14. On the other hand, if you have enough budget, you can definitely go up to 18 to 19 in order to increase the power. Therefore, by having these values, now you can see both the graphs over here, and here you will see the population graph, you will see the sample graph, and you will see the beta error, and you will see alpha beta. Now, let us think of something like we change this particular value from 0.9 to 0.7. Now, I will calculate. Now we will see that if it is 0.7, the total sample size that I may require is only 12, and it is, you can see here 0.7, and approximately I may get 0.71 actual power. And you can see the sudden increase in the beta value over here. Therefore, the power, the type 2 error that we are likely to commit increases as the sample size decreases. Conversely, if you increase the value of power, for example, from 0.7 to 9, you will see the beta value comes down. Therefore, by appropriately choosing different values, you will be able to have a sample size given alpha, power, and effect size. As you know very well, effect size is determined by you, or effect size is given by the data that is there in your hand. You have 450, that is the mean number of hours the bulb is working, and what you actually expect is for 10 only years hours that it is working. The standard deviation is 50 hours. Therefore, when you calculated the effect size, it is 0.8. Now, these are all the major things that you will see here in G-Power software. You can also go to various other tests that are available here. We encourage you to go through the software and test for different kinds of problems that you come across. For example, if you are doing research in the area of human resources, especially relating to some experimental design, please go through the entire literature with respect to your area. And then we want you to find out some of the meta-analyses that would have happened in your research, in which they will be using different sample sizes. You can choose those different sample sizes, test for their power, and then try to find out appropriate sample size. Please do contact us through the discussion forum for any questions relating to G-Power. I have taken a simple test, but you are encouraged to do for various other tests like regression, correlation, and other kinds of research, so that you will be able to get a sample size that has both alpha value and beta value built into it. As you can see in the reporting results, you are expected to report both effect sizes as well as power. Now, as you have a software which can help you in doing all the complex calculations, you will be able to concentrate more on your domain area in order to have good results which can be published. The output of G-Power can be used as a reference in your thesis, and you may also use the large repository of tests that have been given in the internet regarding G-Power. Thank you very much.